they're working on. So it might just come and go, but that shouldn't be a problem. Let's get back. So I was asking someone to give a brief. People aren't speaking, so I'll have to ask someone to speak. Bhumika, are you there? Why is the energy so low today? Means I am
Yes,
suffering.
Neha.
Yeah, hi.
Can I?
Hi. Yeah.
Yeah.
Thank God, at least people are trying to speak. I am having cold and fever, and you guys are low on energy. Why? Anyway, so Ati, you can speak.
Thank you. Firstly, we have seen what stable coins are. Like cryptocurrencies go up and down, but stable coins are associated with some other currencies. And then we have seen the MetaMask installation and all. And then we have discussed about what actually is ERC20. And we have seen the difference between coins and tokens, and we have seen our first smart contract on
Okay,
remains.
okay, good. So I hope that other people also remember that, because what we'll be doing today is we'll properly like starting learning about Solidity through its documentation, and we'll start going through the documentation one by one. That is how we're going to discuss the topics. And then during that discussion, in the documentation itself, we have some examples. And once you get the hold of it, we'll be doing other code and other stuffs also. But I think the initial will be a lot of documentation and discussion only. So um, when we start with the documentation and stuff, I'm definitely gonna explain, but I'm expecting other people to answer and not just listen to me. And I need some new people as well, because it's just the same people talking again and again. So I'll share my screen, just a moment. Sure. Okay, so everyone can see my screen, right?
Yes.
Okay, cool. So okay, so as you can see, this is we'll first go to the home. Yeah, so this is where the whole documentation starts, and I think one of the best documentations that I've come across in Web3 is for Solidity. You can just find anything and everything that you need to learn the language. So as you can see, Solidity is an object-oriented high-level language for implementing smart contracts. We already know that. And these are the programs that govern the behavior of accounts within the Ethereum state. So we have already discussed that whatever transactions or whatever operations that we are trying to do, the whole idea to write smart contracts is that we need to remove manual control. Okay. So once a certain thing or a certain event is triggered, all of the following actions to be performed are done automatically, and that is what they say, that govern the behavior of accounts. So whatever behavior is to be shown, that is whatever action has to be done or whatever it is, that is done by smart contracts. Is a curly bracket language designed to target the Ethereum virtual machine. Again, curly bracket language, they're referring to the same thing. If you go here and you will see that, okay, the languages that use curly brackets, so that is why they refer it as curly bracket language. And Solidity is mostly influenced by three programming languages: C++, Python, and JavaScript. This is one reason that we start with JavaScript initially, so that you can get the knack of it, even if you don't know C++ and Python. Then these are the basic stuffs. It supports inheritance, statically typed libraries, complex blah 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 stuff. So we'll directly go to the introduction to smart contract segments, because we have discussed the initial stuff. Now, this I think is the smart contract that we have already seen on Remix IDE, and this is the one that we discussed in the last class. I think Soumya explained it. This was a basic storage smart contract where you're just taking a number and so like basically storing data and putting it out like as output. Okay, so this is written like a little different, right? So you will see that in the last class, we saw there was this variable called number, and then we were storing a value called num into it, and then we were returning that number, right? Here, what these guys have done is that instead of get data or set data or whatever, they've written function set uint x. Uint again is unsigned integer. That day we saw uint 256, so that's like in terms of the bytes. Then public stored data equals to x. They've declared the stored data as a global variable, and then again they're creating this function get with public view returns. Now that day also I said that whenever we are talking about returns, we generally go with view. It just implies readable function and no changes, and then you're returning the stored data. Now what we're going to do is we're going to, just like that, just like the previous class, we'll go forward with every line of code that they have tried to explain and see how to actually understand code in detail. So they say that the first line tells you that the source code is licensed under the GPL version 3.0. Machine readable license specifiers are important in a setting where publishing the source code is a default. So again, I had told you that this license identifier is really important. It can have multiple values, GPL, MIT, unlicensed, whatever it is, but you shouldn't like really skip it. Then again, the next line specifies that the source code is written for Solidity version 0.4.16 or a newer version of the language up to but not including version 0.9.0. This is what is specified by this thing, where we say that okay, greater than equals to means that this particular version is included, and less than 0.9.0 means whatever syntax or whatever value has been given or whatever version you are using, it has to be less than 0.9.0, or there might be compiler issues. Okay, sometimes there's a change in the compilation structure, then sometimes there's a change in syntax, some things are removed, some things are added. So that's like a major factor here. Again, this is to ensure that the contract is not compilable with a new compiler version where it could behave differently. This is what I was trying. Pragmas are common instructions for compilers about how to treat the source code, and that is why they write pragma solidity. Again, a contract in the sense of Solidity is a collection of code, its function, and its data that resides at a specific address on the Ethereum blockchain. Now, we all know that once you're writing a smart contract, we are deploying it on the blockchain. So that is why they're saying that a contract in the sense of Solidity is basically a collection of code and the data, whatever data we want to put in or get or whatever it is, and it resides at a specific address on the Ethereum blockchain. Okay. The line uint stored data declares a state variable called stored data of type uint, unsigned integer of 256 bits. Now the question, the fact is that you may or may not specify uint 256. It takes it as default. Like here, they have not really specified uint 256, but it is considering it as uint 256 by default. But when you're talking about different version where you're talking about 8 or 32 or 16, then you need to specify it along with the variable that okay, this is what bits we are, this is the number of bits that we are talking about. You can think of it as a single slot in a database that you can query and alter by calling functions of code that manages the database. So again, they are trying to explain it, okay, that whatever variable they've declared, we can think of it as a like a single slot in a database, where like you can imagine that there's a program, there are multiple variables inside it, and then there's this one variable which uh, like holds a special slot, sorry, a single slot in the database. And whenever we are trying to fetch anything from that particular variable, this is basically like querying. How many of you are actually aware of how SQL works, or how any query language works? Okay. Okay, so people who know query, they know that when we are talking about variables, sorry, when we are talking about query, it's always a huge database, and we're trying to fetch something. So instead of going through it one by one, we'll write a query. Okay, like when you talk about SQL in general, suppose I have a list of all the participants of who enrolled for this class, right? And there is like a lot of data regarding you, that this is the number of classes that you have attended, this is the college that you come from, this is the state that you reside in. Then if I have to make, if I am doing an event in Delhi, and I want to find a list of students who are residing in Delhi, who have done this boot camp, I can just wherever database that there it is stored, if we are trying to fetch it through SQL, we can just say that, okay, select a student from the, it is in the form of a table, right? You have to think of it as an imaginary table with rows and columns, and you will be like, okay, select student, or select name and address or state or blah 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 of students, or from the table student where state equals to Delhi. So you give a condition and you filter it out. There might be like thousands and thousands of students, but you're specifying it as a proper query that, okay, this is the condition, that student has to reside from Delhi to that is the data that we need. So here also they're saying that whatever variable that you're talking about, you can think that it is a part of the database. And whenever we're trying to fetch anything, or we want to make any changes in the code, or whatever type of functions we want to do, it's basically like you're fetching a query in the database and then alter it again. There's a change in data, you might make any kind of changes or stuff by calling functions of the code that manages the database. Okay, in this example, the contract defines the function set and get that can be used to modify or retrieve the value of the variable. Okay, so set and get is also like that one name that can specify that, okay, fine, this is the set is always termed as that you're giving an input, and getter functions or such functions are always about output. Okay, that here you're trying to fetch the output or whatever, so they've specified it as like this. Then to access a member like a state variable of the current contract, you do not typically add the this dot prefix, you just access it directly via its name. Then again, in JavaScript, we have said that we have learned something about us this method, right? So it is used to call an object. It was whenever we were referring it in a function, it always talked about ownership. Okay, who it belong, like which object does it belong to, and depending on what type of object you're trying to fetch and all of that. So this is saying that if you have to access any member, okay, like a state variable or objects, if you're talking in terms of JavaScript, you do not have to do like this dot and then object name as the prefix. Okay, so you don't need like this operator here, you can just directly access it by its name. Unlike in some other languages, omitting it is not just a matter of style, it results in a completely different way to access the member, but we'll discuss about that later. Again, this is not important. So this is what we were trying to explain here. Okay, so they've given you like a basic view, and they'll discuss about the other segments also. Like I already explained you that how to go forward with public, how to go forward with view, and all of that. So then again, there is this Yeah. Then there is this again, the another example that goes as sub currency example, right? So that day I did show you the process of a token creation on the blockchain, right? So they're also talking about a similar thing, right? Instead of importing that ERC20 framework directly from Open Zeppelins, they've done everything from scratch. Okay, then how this has to go. So you'll be able to send coins or each other. Okay. So this says that the following contract implements the simplest form of a cryptocurrency. The contract allows only its creator to create new coins. Different issuance schemes are possible. Okay. So they're talking about issuance schemes as well. That is not something that we have to focus on. The idea is that we can create new coins and anyone can send coins to each other without a need for registering with a username and password. All you need is an Ethereum key pair. So, okay, this anybody from the crowd who would like to take a attempt to explaining this code to me, maybe just try. That there is a definition later on, and you can always take a read at it and like talk about it in your language instead of just reading it out loud. But anyone who would just want to go forward with the explanation.
I would like to try.
Yeah, Garima, do it.
So the contract's name is coin, and here we are taking address of the minter, that means the owner here, and then we have mapping here of address to UN, that is matlab, this will map the address that we have taken of the minter to the balance that he or she has in his account. Then there is a event that will send the amount of the from address to address, and the amount is mentioned here. Then when we'll call this contract, then the constructor will be called automatically. That means we have to give the minter address in it maybe. And there's this function mint that requires us to give the receiver's address and the amount that needs to be sent. Um, yeah, and message dot sender must be equals to minter that was provided, and the balance in that receiver's account will be added here.
Okay.
And then
Hmm.
here's this error of insufficient balance that will be thrown if that amount is not there.
Yeah. Okay.
And there is this function send. It will send the amount if it's there, like it's checking the condition. If amount is greater than balance, then it will send. Otherwise, it will revert insufficient balance error that is there. And then it will subtract the amount from the balance sender's account and add it in the receiver's account. And here this event is called emit.
Okay. Fine. Good. So okay, so she gave us like an overview, and you can see that there are already comments written here, right? That can like make it more easier for you to understand the code, right? So someone else who would just take like a more elaborative description here, like how do I explain things to you? So I say that okay, this particular license line is there, this is what it actually means, or this pragma solidity line is there, this is what it actually means. So what Garima explained is like a whole overview that okay, this is what is happening, this is the address, blah blah blah. But what I want is that I want someone to go through each line. Start from license identifier, go to pragma, then talk about contract coin, why that keyword is used. What do you think address public minter stands for? What does mapping address UI in public balances stands for? So I want someone to attempt it like that. Like not more of a general view. General she's beautifully explained, but I want someone to just go through it line by line and tell me that what do you think this particular line is doing. Come on. We have 51 participants. How can like all of you guys just be inactive today? Sindhu, are you there? Okay. I don't really understand that why do people attempt the session if they're not really present during the session.
Hello,
There are
ma'am.
girls. Yeah.
I would like to give it a try.
Mm. Okay, wait. Who is speaking? Can't even see. Yeah, go on.
Can you scroll up a bit, like from the beginning?
Yeah, sure.
So, firstly, the first line tells us the license that is specified for this contract, that this contract is under which license. Then we have Pragma Solidity. This basically mentions the version of Solidity we will be using for this code.
Okay.
Next, we have the
1 minute.
contract named
Vanshika.
coin.
So,
Yes, ma'am.
okay, so you're saying that the first line talks about the version of the solidity, right? So why didn't we like? So what do you think that exponentiation mark specifies? Is it that we can just use 0.8.4 or below or above? What is it?
I think we can use versions above this.
Yeah. So you can use version 0.8.4 and above. So that is why we are doing exponentiation marks. If you see that, sorry. So if you see this segment, you will see that when they're trying to be very, very specific, that there might be compiler differences. They just specify that, okay, this has to be greater than equals to, and this has to be limited, right? So when you're putting exponentiation, that means any version above like including 0.8.4 and above is compatible. Okay. Okay,
Okay.
fine. Continue.
So then we have the contract defined. Its name is coin. Firstly, we have where we take the address of the minter, that is the person who creates the whatever asset or something we will be trading. That is
Mm-hmm.
the address of the minter. So now we have a balances array has has that kind of stores the balance in the account, in the virtual account of each of the owners or whoever is in this marketplace currently, I think. So we are trying to find that address in this array. So we are mapping this address we have to the event data type to get the name of the minter in that balances array. So then we have this event called send, that takes three parameters: the address of the person who is sending the asset, that is from, the address of the person who is receiving the asset, that is to, and the amount. Then we have a constructor. So constructor is will be called automatically. So we are assigning message.sender. I think it automatically detects which person is sending the message. So we are assigning that that message.sender to the variable minter here. So minter now stores the name of the person or the contact address of the wallet that is sending the amount. Then we have the function mint. It has two arguments. One is the address of the receiver, the other is the amount. Public keyword specifies it is uh, publicly accessible. First, it checks the condition that it requires for the owner of the amount to be the minter. And when it has checked that condition, it increases the balance amount of the receiver with the given amount. Then we have error insufficient balance. That raises an error, that is, it has two parameters, that is requested and available. So it checks if the requested amount is greater than equal to available, so then the transaction should not be able to take place. So that is the error it is checking for. Then we have the function send, that is two parameters, receiver and amount. So again, it checks if the amount is greater than the balance of the sender, then the transaction will not be able to take place. So revert kind of returns us an error which will have this information, that amount requested and the balance available, so that user knows that why the transaction was not able to take place. Um, if the error is not raised, that means the transaction can take place, and it decreases the balance of the sender by the given amount. It increases the balance of the receiver by the given amount, and calls the sent event, emits the sent event.
Your mic is not open.
Sneha, you're muted.
My bad. My bad. I am coughing too much, so I put it on mute. Okay. So when we're talking about contract coin, we had discussed it in the last class that for the compiler to know that, okay, this is where the contract actually starts, instead of a class keyword in other languages, we use contract keyword, right? The name of the contract is coin. Now it is saying address public minter. Okay. So everyone who's who will be trying to mint the token. So address is basically that it's a data type in Solidity, which is talking about the address or which will hold values of our wallets. Okay, like wallet addresses. Just like in other languages, when you're talking about string data type, right? You know that it has something that might be like a letter, a word, a sentence, a paragraph, whatever, right? So in address, we are talking about the addresses of the wallet. Public is again the keyword that they're using to specify. The keyword public makes variable accessible from other contracts. You have to like fetch, or you have to, there are situations where you want to extend a particular, if you're working on a project and you want to create a coin for it, right? So create a coin from it. So you might just not write a new contract and you'll just extend it, extend this particular contract for that, right? So then if you're putting keywords, it's public and all of that, you can fetch it while you can make use of this particular variable outside the contract as well, like from other contracts as well. So we're talking about that. Mapping address uint public balances. Now mapping itself gives you a very clear idea that we're talking about mapping values. Now, what values are we mapping? We're mapping address and uint. So that means there's an address variable that stores the data of the wallet as that stores the wallet addresses of the people or someone who's initiating the smart contract or using the smart contract, whosoever is triggering it, right? With a uint value. Now, what do you think that uint value will be? So that is where they're specifying public balances. So that means every address is mapped with the balance of what they have in that particular address. Now, suppose in my MetaMask wallet, if I have $60 worth of ETH, that is what will be shown. So my address with whatever 0xA07 blah 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 will be mapped with this particular value. Now, why is it done? It's basically a database that they're trying to maintain, that if a smart contract is initiated from my like my account, okay, and I created 1,000 or a 1 lakh coin, or I have 1 lakh coins and I want to send it to Vanshita, okay. So if I'm sending 50 or 500, they need to have a database that specifies that, okay, this is the balance that was there initially. In the further code, you will see that, okay, this is the amount that she wants to send to Vanshita, and then this is the outstanding amount. That is why a mapping is required, okay. Then event sent address from address to uint amount. Now anybody who would see this line, if they don't, even if they don't know Solidity, it's very easy for them to guess that they're triggering an event called send, where they're taking values as address, like from to. That means if I am sending the coin to Vanshita So address from will include my address. Address to will include Vanshita's address. And event amount will include the amount of coins that I want to share, right? So events allow clients to react to specific contract changes you declare. Then again, constructor. Okay, constructor code is only run when the contract is created. Just like in JavaScript and other languages, whenever an object of a class is created, the constructor is automatically invoked or called, right? The number of times you call the object or you create an object, the constructor will be automatically created. So similarly, when the contract is created, the constructor will run automatically. That you're saying that minter is equals to message.sender. Message.sender is, but message.sender is again a default value, I think, or I would say a built-in method that these Solidity people have defined, that automatically stores the address of the person who's invoking the smart contract or calling the smart contract. That is why the value is inside minter. Okay, so here you would have seen that we have already declared a variable of data type address called minter, right, where we were storing the address, and here we are assigning that value. So if I am initiating a smart contract transaction, I am the message.sender. If someone else is doing it, they are the message.sender, and message.sender will have your account's address value. Now this is basically to maybe reduce errors, that if you keep on writing that address, you might just miss out with, because it's a long address, right? You might just miss out with one unit, one data. And if there's like any change, if suppose even just like in phone numbers, if the number has a 9 to it and instead of that you write 8, the call will connect to someone else, right? So similarly, if you're making any error in your account address, that account might just belong to some other person, right? So all of the transactions will happen there. And it's like I mean, there are processes where people are like or people are working to like revert transactions if there's an error or something, but then that's like that takes like a lot of mechanisms and other stuffs, so you can't even undo it. Okay, so in order to remove maybe such ambiguities, such errors, we're talking about message.sender in general. Could you please repeat the mapping thing? Okay, sorry, I saw it right now. So when we're talking about mapping, okay, this mapping is basically just imagine, okay, just imagine that I again the same example that I was talking, that if I have to create a database of all the students who are attending my Solidity cohort, and I want to know from where they are coming, right? I can't just continue asking each one of you guys. Right? If you're 50 people, it's fine. But if you're 500 people, it takes a lot of time. So what we do is that if we have your data, if you have filled a form or whatever, your name is mapped, or your name, just like if your name is there, suppose Swati is there, right? And if you come from Delhi, so there will be a column state that will state Delhi just right beside your name. Okay, then there will be a college name just right beside your name that specifies which college you come from. So although we're seeing it in a tabular form, here imagine such a tabular form of data, and you all what you're saying is that my name is mapped to my data. Okay, because it is in the same column. We can never do this, that we list your name as Swati, Vanshita, Prisha, Garima, Soumya, and then just mess up with the state, that the state you belong to is written in Prisha's, and the state Prisha belongs to is written in Vanshita's. No, there has to be a proper sequence followed, that your data is only written beside your name. So it's a kind of mapping, that whenever we'll search for Swati in the database, all of that data shall come because it is mapped to your name. Okay, so this is what they're doing. They're mapping the address value. So mapping has a particular format. So you write mapping as the keyword, and then you give the brackets and you specify the two elements that has to be mapped. It can be more also, like multiple mappings can also be done, but you specify the two data types that you're talking about. In this case, they've written as address and uint. That means the mapping is done between a address data type and an integer data type. Okay, Now again, uint they're specifying. Now that uint can be anything, but in this case, that's when you're writing mapping, you would specify that what is it that you want to map to, right? So they say that okay, that uint value is basically balances. So what balances of what? The balances, the balance that is that belongs to that particular address. So address itself does not need any specification. It's the wallet address that you're talking about. But that uint value can be anything, right? So they have specified that no, we're talking about balances here as the uint value that we are mapping. Is it clear now? Okay, fine. Okay. So we were here, right? We talked about minter is equals to message dot sender. Then again, in this line, you see that function mint, okay? Address, receiver, uint, amount, public, right? So you can clearly see that there's a function mint that's specifying the address of the person who's supposed to receive that particular uh, coin or whatever that we are sending. Here coin, but in general, it can be anything like any cryptocurrency, any token, whatever it is. And then you have to specify uint amount, right? So this is the amount that we have to say. And then again, it's public. And it says require message dot sender equals to minter. Okay. So people obviously might not know. Those who don't know Solidity, they might not know what require is. But if you're looking at in the form of an English language, you will see that, okay, this require is basically like there are certain situations where we mention something as this is requirements, right? That means these are mandatorily required. If there's mandatory requirement or this is what we expect from you. So similarly, require here is a kind of authentication process. And what is it doing? It is saying that you have to check that message dot sender equals to minter. That means that the person who's initiating the smart contract, okay, or trying to send the coin is the minter itself. I mean, if I am trying to invoke a smart contract and I am trying to send the money, it has to be my address, right? I can't just. Is it analogous to if statements? Yeah, I mean, you can say it that because obviously if this require message or sender equals to minter doesn't work, the transaction won't move forward. It has to be mandate. So you can say like if statement because it's specifying the condition, but then there's no else or something. Like there can be that it will throw error or something, but yeah, it's a kind of conditional statement only that is used for authentication process. So just like suppose if you're trying to change the password of your account, okay, so Google will always give you send you this thing that verify that it's you, right? So either it will send you an OTP or it will ask you for your security question, whatever it is. So that is that, okay, not someone else should not be able to change the password, okay? As we equate minter, no, we are not equating with, see, what we are doing is, again, this is, yeah, okay, this is a nice question. So we are putting minter is equals to message dot sender, right? So in this message dot sender has an automatic value of the person who's invoking the smart contract, right? Suppose I invoke the smart contract, so message dot sender has my address, right? So that particular address is stored in minter. But while I have to send the money, okay, so I've initiated the smart contract, but then I'm using some other account, someone else's account to send that address, and I've not initiated the smart contract from that, then it will not be the same value. Then whosoever is sending or whosoever is performing the transaction, that person's account address will automatically come in. Okay, so minter will have my address because we have stored initially. And then again, since I'm performing the transaction from some other account, that address will be stored. So it will not be equal. That authentication will fail. I mean, it's how do I explain it to you in a simple format? It's exactly like you are saying that because a phone belongs to me, okay, that is mine. No. Or if I unlock the phone, that is mine. No, that is not required. That is not like really true. If you are staying with me and if I know the password of your phone, I can unlock the password, right? I can unlock your phone using your password. But if I'm initiating a transaction, if I'm using your Google Pay, the UPI pin is required, and it may or may not, because the phone is not mine. The moment I put it, the incorrect UPI pin, the authentication will fail. I mean, it just, this is for equating and that is for checking the values are equal. Yeah, so the no, single equals to is always for assignment and double equals to is for checking if the values are equal, right? So like I got what she was trying to write, equate Minter, but she's basically asking that if we had already put the value as is equals to, like if I say that okay, a equals to 5 and then I say check if a equals to 5, there has to be something that has changed, and that is why I need that kind of verification, right? So I'm trying to explain that. So it is not necessary that if you have put Minter is equals to message dot sender while you're initiating the transaction, it will have the same value. So that authentication is really really important. So I hope that made sense to you in some way. I mean, I think I could explain it in a better manner with a better example. But then again, just because you are present, if you are inside a house or if you have someone else's phone and you're able to unlock it, that is not an authentication that that phone is yours. There can be multiple scenarios. So that is why we're still putting this line that okay, I know that if that Minter has been assigned the value of message dot sender, but let's check again, because what if someone else is initiating the transaction? Okay, so that is why they're checking this. If this will not be there, it will fail. Okay, if the required thing fails, the contract will stop execution. Balances receiver. So again, receiver's balance is fetched plus equals to amount. Now again, since I am sending the amount to the receiver, whatever balance the receiver has. Now, the thing that you have to note here is that this is the keyword that we are using, right? This is the mapping keyword that we were using here, like along with mapping, this was the keyword, sorry, not keyword, variable name that we are using. Now, this is how we are fetching it. We are using that variable name, and we are specifying receiver here, which we have passed as an argument. And we are saying plus equals to amount, whatever balance you have. If I sent you 1,000 tokens, you have to add 1,000 to the balance of the receiver. This is when we are sending the token. Again, there can be multiple scenarios where either you don't even have that kind of money, so the transaction has to fail. And the second step will be, if you have that kind of money, that money has to be deducted from your account. So this is what they're saying, that you create an error called as insufficient balance, uint requested, uint available. Again, they've passed this numerical values as requested, and then again the available will be whatever amount is available. Errors allow you to provide information about why an operation failed. They are returned to the caller of the function. So again, this is to have like more transparency, more easy debugging. Error will always return to the caller of the function, and it will show that this is why your program failed here. Okay. Then function send, address of the receiver, uint amount, public. Now here where they are checking everything. If amount greater than balances of message dot sender, it's not Minter, it's for sender, right? Because message dot sender has the address of the person who's invoking the smart contract. So we are saying that if the amount that has to be sent is more than what the balance of the sender is, okay, revert insufficient balance. That means it will go back to the error. It will revert the pointer to the error statement, insufficient balance. And you have to give out requested amount, available balance. So this is how you get the clarity that okay, this was the requested amount and this is the available amount that you have. If not, if this condition fails, that means you have sufficient amount. The amount is not greater than what balance you have. Balances message.sender minus equals to amount. Balances receiver plus equals to amount. Emit sent message sender receiver amount. Then again, emit is working as an output for you, right? That the send function has worked from the message sender to this receiver to this address. Again, this sent will be here. This is the event that it is initiating. So event and emit will always go hand in hand. Emit will always talk about an event. Okay, that will always point to an event. And you can see that the parameter that we passed here was address, like a data type address from. That means if I am sending, from will have my address, right? And that means from will always have the address of the person who is running that smart contract. That is why we are having message.sender. Then address to whosoever you're sending. In this case, we have the variable receiver. So receiver is the parameter. And uint amount. Then again, because this declaration has been done and it goes hand in hand, you just directly pass the amount. So this is like the basic explanation. Okay, so basically, when you're talking about event and emit, it is there to show you that that okay, this part, this particular thing has executed. I mean, I can if you will see here, like a better definition on how to go forward with it. I don't know if I've talked about here. Uh, no, they haven't talked about it here. I think event and emit. Okay, so emit is basically just like in JavaScript, we talk about async and await, right? So await never really had like a special function to do. Async function is declared, okay, that this particular function is gonna be asynchronous, and for every async we'll have these awaits. This is where it will take time, where it will take time. So similarly, the event and emit thing is working. Okay, so it's just a way to show that okay, this particular function, this particular event has occurred. It is just for accountability that okay, this event has occurred and this is the argument that it has passed. It's just for accountability that okay, this has been done. Is it clear? Like we'll talk about event and emit later also, but it's basically just for accountability that this particular event has occurred. Just like you do like a print statement along with after await, that console.log, okay, transaction done. So that execution will just give you an accountability that okay, this thing has successfully happened. So similarly is with event and emit. Is it clear? Who asked that question? Vinita. Okay. So again, we'll just take a read at this. This contract introduces some new concepts. Let's go through. The line address public minter declares a straight variable of type address. I've already specified address is always about the data type. Here they're saying state variable of type. Same thing. The address type is a 160-bit value that does not allow any arithmetic operations, obviously, because it has the address. What arithmetic operations are you going to do with the address, right? So that is why it does not allow any arithmetic operations. It is suitable for storing addresses of contracts or a hash of the public half of a key pair belonging to external account. Again, jargon terms, but what you have to keep in mind is that it can store addresses of contracts or the hash of the public half of a key pair. That means whatever thing that fits under the maybe address, not just the contract address, but even the hash, when you're talking hash value that we're talking for the key pairs, then you can store that as well. The keyword public automatically generates a function that allows you to access the current value of the state variable from outside of the contract. Again, if it was some other anything except public, there will be restrictions if you want to like keep some function as private or for security purposes or so. But if it is public, the current value for that particular state variable can be even fetched from outside the contract. Without these keyword, other contracts have no way to access the variable. Okay. The code of the function generated by the compiler is equivalent to the following: ignore external and view for now. Ignore external. Okay. The code of the function generated by the compiler is equivalent to the following: ignore following, ignore external. Okay, so it is saying that this was it, right? This function minter, function function minter external view returns address return minter. Okay, so this is saying that if you're not using that keyword, okay, then it's basically there's no way you can access the value from outside. And you can also write it like this: if you're not declaring the function as that, you can just have an external keyword with the view statement, and in Solidity there's only public and private or any other access specifiers available. No, you can't say that there are these access specifiers like in other languages called public, private, or protected. It goes to many such I won't say access specifiers. I would say there are these keywords like public, external, pure, view, that just limits according to what the requirement of the smart contract is. Okay. So we'll talk about all of that. There are like a lot of terms, extra terms in Solidity, which is just impossible to remember. And it will change according to your requirement. So even when I am writing a Solidity code, I don't even know like, okay, should this keyword be used here or that keyword be used here. But then according to the requirement and whatever operation you want to do, you'll always have to figure it out on your own that, okay, if the compiler is throwing an error, that is not the right keyword that you're using. So let's not like hurry into knowing everything, just deal with it one by one. Okay. So again, you could add a function like the above yourself, but you would have a function in state variable with the same name. You do not need to do this. The compiler figures it out for you. Okay. So since we are already putting the whole thing as this is what they're talking about, right? Address, public, minter. Instead of this, okay, if you had to write a function for this, whatever value you're getting from this is the function, this is how the function will look like, right? So it's saying that you could add a function like the above yourself, but you would have a function and state variable with the same name, right? So there's a variable also and the function also with the same name. So there's no need to do that. The compiler will make it easy for you. Just specify that address and make it public and minter, so it knows that, okay, it has to have the address of the minter. Okay. The next line, mapping address uint public balances, also create a public state variable, but it is a more complex data type. The mapping type maps addresses to unsigned integers. Okay. Mappings can be seen as hash tables, which are virtually initialized such that every possible key exists from the start and is mapped to a value whose byte representation is all zeros. Okay, bullshit. You don't have to remember such definitions. It is for you to understand that, okay, what does mapping in general means. Okay, you're mapping certain value to a certain value. But when you're talking about Solidity, that is where they're explaining that, okay, mapping is a term that has generally been used with hashing, the hash tables, where there will be a key value pair. Okay, if there's a lot of data, it is assigned that, okay, zero key has this value. Or even an array, right? There is indexing. So array at index 0, suppose as name Sneha. At 1, it's Garima. At 2, it's Vanshita. At 3, it's Swati. So these 0 is mapped to Sneha, 1 is mapped to Vanshita, 2 is mapped to Prisha, whose it is. So that mapping is basically to make things easy for us. So that is why it's referred to as key value pair. So similarly, here also they're saying that it can be seen as hash tables, which are virtually initialized such that every possible key exists from the start and is mapped to a value's byte representation is all zeros. So they're storing all the values in terms of byte representations, and whatever way they're storing it, that is not important. You just need to know that what mapping does in general. Okay, so that if tomorrow you're writing a smart contract that needs to store suppose the address with any kind of data on chain, you can just know that okay, this is what is required. Okay, this is where we are using mapping. However, it is not neither possible to obtain a list of all keys of a mapping nor a list of all values. Record what you added to the mapping or use it in a context where this is not needed, blah blah, not required. Again, the getter function created by the public keyword is more complex in the case of mapping. It looks like the following. If you are creating this thing as how do I say, if you are writing a function for it, okay, that will make like it more complex. Function, balances, address, account. That means you're creating a function balances, you're passing a argument of address, account, and then there's a keyword external, view, returns, uint, return, balance, account. So that's like you completely wrote an entire new function to just fetch the balance of every account. Okay, so it goes more complex. That is why we're doing it in one line. We're just mapping addresses to a uint value. What is that value? So it has to be balances, which is made public so that it is accessible from outside also. You can use this function to query the balance of a single account. The line event sent address from blah 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 declares an event which is emitted in the last line of function send. Okay, again, which is emitted in the last line of function can somewhere be like event is declared and it is emitted. That means it is executed in the last line of the code. Okay, or last line of the function send. So they have created this function and they're calling or specifying that, or maybe triggering that event in the last line. That is what they're specifying. Ethereum clients such as web applications can listen for these events emitted on the blockchain without much cost. Okay, as soon as it is emitted, the listener receives the arguments from, to, and amount. This is why the way we have declared the event in a similar pattern only, we are writing emit. An easy way to explain this is that suppose you're creating a function with three arguments. Okay, name, age, and address. Okay, not in Solidity, in any programming language you're creating, or in fact in so many codes that we have seen. Suppose we have created a function called product and we are passing two arguments, a and b, right? We don't really specify the value in that case, right? We can, but we are not specifying at that moment. And then when we are calling the function, then we are passing the values. Again, if the function declaration has been done in such a manner that first value is a string and second value is a number, if you're calling that function, the same sequence has to be followed. You can't give a number value in case of in the first order of the string data and a string data for the number one. The sequence has to be followed because that is how the data will be mapped. If you are creating a function product, uint a, uint b, sorry, int a, int b, not talking about Solidity in general, int a, int b, and you're calling that function product 5,6. So a will automatically be put the value as 5 and b will automatically be put as 6, right? So this is how event and emit is also working. The moment the emit keyword is triggered or the emit line is executed, the listener receives the arguments from to amount, which makes it possible to track transactions. So since it's basically like calling an event in that case, so all the data that has been, or all the argument that has been passed in that case is fetched. To listen for this event, you could use the following JavaScript code, which uses web3.js to create the coin contract object, and any user interface calls for automatically generated balances. Again, they're saying that if you are if you want to listen to the event, okay, again, I think we talked about this when we were creating events. We didn't really talk about listening of events, but if you want to get hold or see a data that is associated with that, that is why we're saying to listen for this event. This is a JavaScript code that you will write. So you can say coin.send.watch, and whatever this value is empty. This value is empty. Function error comma result. If not error, console.log coin transfer, and then result.args.amount plus coins were sent from result.args from result.args to. Now you can see that when we are talking here, where did it go? This error, right? Function error we were talking. It's talking about error and the result, right? So it's fetching through that object. That means it's specifying that, okay, this parameter has been passed. Then we're talking about arguments, and then we're talking about amount. Amount was also passed in that event. From was also passed and to was also passed. If you look at this line, where is it? Yeah, from, to, and amount, right? So same way. And sent was the name of the event. That is why here we are specifying as coin.send and then dot watch, and then we are passing it. And that if there's no error, that has been triggered, this is the console log that will be printed. Okay, this is basic. Now if you run this script code, what will it do? If the transaction has happened, it will show you that, okay, coin was sent from this address, this much coin was sent from this address to this address, amount was this. So that is what you're talking about, event listening. You're just taking hold of it. You can't listen to the event, right? But in terms of programming, that listening is basically maybe to have the accountability of that event. Okay. Console.log balance is now sender, coin.balance.call, coin receiver, coin.balance.call. So if this was not working, this will work. So if there's an error, this. So we had said that if the error will happen, the values that we're initiating will automatically be returned to the caller of the function, requested and available, right? That is what they're doing. So sender's balance and receiver's balance. The constructor, again, that's explaining the next lines of code here. Now we are here. We have talked about event already. Where did it? The constructor is a special. Okay, till now, is there any doubt? It might be a little overwhelming for you. The code is not really very difficult to understand, but there are a lot of terms. There are a lot of ways you can explain or understand it, but it is a little complicated initially. And don't get too worried with this. It's just an example that they're stating. This event was to be listened in terms of a JavaScript code. This is how you will write it. That doesn't mean that when you're doing a project you literally have to write that. So you don't have to worry about that. But till now, is everything clear? Okay. How many of you find it a little overwhelming? Do you want me to go a little slow? Do you want me to go fast, or the speed is fine for you? Okay, Swati is finding it overwhelming. Meghna is also finding it overwhelming. I mean, we can always go slow. What do you think? Should we go slow? The speed is fine. Okay. I mean, you'll have to do like a lot of work initially on your own. But I think, okay. Others, so how many people, it's not overwhelming at all. It's like, okay, we are gonna be Solidity pros very, very soon, and we don't really find this thing overwhelming. Okay. Fine. Then we'll talk about this. The constructor here is a special function that is executed during the creation of the contract and cannot be called afterwards. Okay. So again, just like for class and objects, every time an object was created, we were talking about constructor being called automatically. But here, constructor is only called when the contract is created. So you can't we are not storing mapping in any variable. So can't we able to access balance using address? No. Again, good question. I mean, see, we don't have to, so you have to understand it this way, that if you're not using mapping, okay, this was the function that we could have written, okay, where we can obviously fetch the balance of a person from their address, right? But this is how the function will look like, and this is complicated. As a developer, your focus should be reducing space complexity, reducing time complexity, and making the code optimized as much as possible, right? So what are these people doing? They're saying that if you were not using this line, mapping address you in public balances, you could have written a getter function balances address account external view returns blah blah blah. What are they doing? They are possibly providing the account address of the account, and they're trying to fetch the balance, and they're trying to make it public as well, so that in case you need it from outside, it is accessible to you, right? But you can't change it. That is why there's a view returns. So you can always do that, but it says that getter function that is created by the public keyword is more complex in the case of a mapping. It looks like the following. So that is why you should leave that in for the compiler to do everything. So the mapping thing has been created, and if you should always go by it, because writing this function can so see, we can't really see we when we talk about time complexity, space complexity, when you're writing stuffs and you know that okay, this code has two loops inside it, okay, so there's a for loop and there's a for loop inside it. You know that if both are running to n, it will go till n square, right? But if there's a way where you can reduce it to O of n, that is the space complexity of sorry, time complexity of n, then you'll always go for that optimization, right? Here we're not able to figure out how the compiler is storing things. Like, I mean, that goes like really deep in terms of explanations. So you don't know that how is the complexity actually increased. But what they are specifying is that if you write a function like this, might be that there has to be like a lot of iterations. It might take a lot of time to fetch data, but mapping works faster because it will automatically map with the key value pairs and arrange, right? So it might be it in that case it is less complex, and that is why they're saying that okay, since if you're creating a function that goes complex, you should always go for mapping. Or in that case, if I have to give you a layman example, it's like if if you're asked to make a line for your class, okay, like make a line of students according to roll numbers, right? And you like, okay, roll number 1, roll number 2, roll number 3, blah blah blah. That will take time. If there are 100 students, it will take 100 iterations for you to call 1 2 3 4 till 100. But if you say that okay, people, according to your roll numbers, just stand in line. So you give the access to people. They know that okay, if I am roll number 23, 22 is this person, 21 is this person, they automatically arrange themselves in line. That will, until unless they actually try to create a chaos, that will always be more optimized in terms of time, right? So that is an example that you can see. That is what they're trying to explain here, that maybe they're just saying that okay, if you're creating a function for this thing, it will be complex. Okay, so that is why we go for mapping. That is why they're trying to use mapping. Is it clear now? I mean, does the example make sense to you what I'm trying to explain? Okay. Fine. So then again, where was I? I forgot. Yeah, constructor. So again, constructor is only called when the contract is created, and here we are creating one contract. So constructor will always be called once. You can't call it afterwards. In this case, it permanently stores the address of the person creating the contract. The message variable together with TX and block is a special global variable that contains properties which allow access to the blockchain. Message.sender is always the address where the current external function call came from. That means whosoever was calling that particular function externally, or maybe in other words, we can say that we were invoking the smart contract, executing the smart contract. The functions that make up the contract and that users and contracts can call are mint and send. Okay. In this case, the mint function sends an amount of sorry. The mint function sends an amount of newly created coins to another address. The require function call defines conditions and reverts all changes if not met. In this example, require message of sender equals to minter ensures that only the creator of the contract can call mint. In general, the creator can mint as many tokens as they like, but at some point, this will lead to a phenomenon called overflow. Note that because of the default checked arithmetic, the transaction would revert if the expression balance receiver plus equals to amount overflows. That is when balance receiver plus amount in arbitrary precision arithmetic is larger than the maximum value of u in 2 to the power 256 minus 1. This is also true for the statement balances receiver plus equals to amount in the function set. Okay. Lots of details, lots of things to focus on. I had already explained that require message or sender equals to minter is basically acting as an authentication process, right? So a person who's minting shall be the person who's creating, who's calling that smart contract, right? That is why we are providing that authentication. And if I am initiating that smart contract, that means I am trying to create a token. I can create as many tokens as I like, but there's still a limit, and that limit is what that if that limit is crossed, there's a phenomenon called overflow, which we have heard in general also. Now the most basic example of this in other programming languages, that if you go for an integer data type, okay, there's a certain value that is assigned to it. I think 2 to the power 32 or something. No, I forgot. Whatever value it is. And if you have to store any data that is above that, you go for double, you go for float. Okay, you go for decimal, whatever it is. So it's there's a hierarchy in terms of the storage that is possible. So similarly, these people here are saying that I can create, as a creator, I can create as many tokens as I want, but still there's an upper limit. That upper limit, if it crosses, overflow will happen. And what is that upper limit? It is a value of 2 to the power 256 minus 1. Okay, and it will happen for all the values, because all the values that you have declared as u in 256, because that is the data that it can actually store. Errors, so this part is clear, right? I mean, there were 2-3 things to focus on. I think that is clear. Can you just quickly reply? Okay. Okay, then we are coming to the error statement. So errors allow you to provide more information to the caller about why a condition or operation failed. Okay. And they're used together with the revert statement. Now, if you see here in the code, you will see that it was revert insufficient balance. And this insufficient balance is the name of the error that we have created. Yeah, it's the name of the error that we have created. So, is it? Yeah. So errors will always go together with the revert statement. Whenever you're declaring a error, you'll always have to write a revert statement in the contract that will take you back to the error statement and give you the required output. The revert statement unconditionally aborts and reverts all changes similar to the required function. So if the condition is not met and there's an error, the revert statement will execute and it will abort and revert all the changes, similarly like record function will do. So it will automatically abort whatever operation has to be performed. But it also allows you to provide the name of an error and additional data which will be supplied to the caller. In this case, we were talking about the balance. Error, insufficient balance, requested, available. So the person has a greater idea that okay, this is why it failed, right? So this revert statement is basically giving you this additional information, that this is the name of the error, this is the additional data, and it will be sent to the supplied to the caller, and eventually to the front end application of Block Explorer. So if you're interacting with the smart contract through a front end uh, application, it will show you that okay, this failed, this was a problem. If some transaction fails because of a gas fee less, yeah, I think we saw it in the last class when is trying to execute without the test token, it will show you that insufficient gas fee or whatever. So that error is displayed, okay, along with some data. So the send function the send function can be used by anyone who already has some of these coins to send coins to anyone else. If the sender does not have enough coins to send, the if condition evaluates to true. As a result, the revert will cause the operation to fail while providing the sender with error details using the insufficient balance error. Again, if you do not have enough coins, the if condition here the if condition here will amount to true, right? Because that is where it checks if amount is greater than the balance of sender. As a result, the revert will cause the operation to fail while providing the sender with error details using the insufficient error balance. So when this revert thing is working, uh, it will show the sender that this was the amount you requested and this is the amount that you have available. So it's again the same thing. Okay. So is this whole smart contract clear for you with respect to all the terms that we have used? This question is for everyone. Is it clear in terms of all the words, all the new keywords, all the statements that you have used? No, we have talked about. Okay, cool. So one task that you have to do is it's not an assignment or something. It's just a follow-up task that you have to do after the class. Try running this smart contract in Remix IDE. Okay, try deploying it and see what result do you get. In fact, you guys are so inactive today. Just do it right now and show me what is the output that you get. Everyone. You have a open in remix option. This is the official Solidity doc. So you can just go to official Solidity doc and open the code in remix and then you can try deploying it. I mean, I haven't done it before. I create contract using the ERC20 framework. Even I will do it, but I want other people to take a look as well. Come on, quick. We don't have like a lot of time to put on it. anybody who's able to do it, just drop in a text in the chat that okay, the deployment, or I don't think so you don't have to deploy it using MetaMask. Okay, you just have to deploy it locally using the Remix IDE. So for that, you don't really need the test tokens or whatsoever. Just try doing that. Okay, the remix is slow. Yeah, people who are just getting a blank screen, you can see my screen also. It's blank, right? So remix takes like a lot of time to load. You got to refresh it, then it will load faster than before. It works pretty slow. Yeah, it will take time. Okay, Garima has deployed, right? Okay. Mint address balance. Okay. So can you try just putting okay, wait, just you have to give two values: address receiver UN 256 amount, address receiver UN 256 amount. Okay, so just try putting any address value, maybe take it from your MetaMask and see. I mean, you don't have to change the environment to MetaMask, because you don't, I'll have to again go through the whole thing of how you need to get a test token from the faucet and everything. Just everyone just try putting an address. I'll put my address here uh, and see what is the output getting. Why are people sending compiler thing? Okay. Yeah, what I was saying was to put values. Mm, I'll just send my MetaMask. So it's getting deployed for everyone, right? Okay. This is not my laptop, so I anyway can't put in my MetaMask. Deploy it, right? How many of you have sent me? 1, 2, 3. Okay. So we'll in probably next class I'll teach you how to do the faucet thing, and how to get the test token so that we can deploy it on on chain and then see how things work. But today we'll go forward with other. Yeah. So they'll ask you for values. Okay. If you give values accordingly, they'll give you some output. What you can do, what you guys can do is put, so okay, wherever you guys have deployed, right? So Prisha has a contract address, the other one has a contract address. Okay. So that will not work. I mean, obviously, if you have to send, you have to give the wallet address or something. But just as an experiment, Prisha can put her contract address, deployed contract address in the chat, and someone else can put theirs. And you can try adding it as address of receiver, address of sender, U in 256 amount, and U in 256 amount, and then balances. Or what you can do is, best is, put that address, put someone else's address, and click on balances and see if you're getting the balance. It will probably be zero only, because there's no balance that you guys, and it's not deployed with the help of a wallet. It's deployed locally, so it's not gonna have any value. But just try experimenting. That is how you actually get to know that, okay, this is the value that we put in, this is how it came out to be, and all of that. And tell me, what did you get as output? Did anybody try putting? Other people also put your deployed contact address in the chat. Okay. See what are you getting if you're putting your account address under balances, or if you're putting someone else's account address under balances. It will probably show zero, some error maybe, or a nil value. What is it that you're getting? Anybody get any output? Did anyone get any output? You just don't have to send the addresses. Try putting these values in those columns, uh, and try executing the balance function. Try executing. Yeah, I tried sending amount greater than in balance. The transaction failed. Okay. Garima, can you send the screenshot of that one? Like, what is the error that you got? Yeah, just, I mean, that was Others also try adding those values and see, click on, last time I showed it to you that once you have to record a particular transaction or execute a particular function, you have to first click on the button that's highlighted, the orange ones. You click on it, then the transaction will be recorded. A message will come in the terminal that shows that okay, this particular thing has been initiated, and then you do the other one, see how it interacts with it. Yeah, okay. So cool. This is a really see, this gives you like a clear idea of what we have been talking about throughout the session. So you see transaction to coin dot send error, VM error revert. Okay, revert as this transaction has been reverted to the initial state. Error provided by the contract. Since we created the name of the error as insufficient balance, there was parameter. What was requested? A value of 12 was requested. What was available? A value of 0 was available. Debug the transaction to get more information. Fine. So now, even though Garima didn't really tell us or how much was she trying to send, it's clearly visible that the available value is 0 and she put a value of 12, right? So when you write error statements and these revert statements, it not just tells you that your contract execution has failed, but it also gives you a clear idea along with certain data and parameters that you can correct, right? So if suppose she had a available value of 10, okay, or she was maybe requesting -1 or whatever, not in terms of coins but in any value, she has available 0 and she was talking about -1, maybe she was trying to subtract something, right? And she sees that, oh, in the error the value is 1, right? Now if then she will know that, oh shit, instead of writing -1 I wrote 1, right? So it's like a quick debugging to figure out what error actually did we make. So that is all that I've been trying to explain you till now in terms of error, in terms of how reward works. I think it's clear for all of you guys by looking at this screenshot. Did someone else experiment with it? Okay, so is it clear for everyone how error works, how reward works, what kind of data is sent to the caller of the function for easy debugging and stuff? Okay, when I added amount in the mint and create transaction to send, it works fine. Can you show what did you try to do? Like in terms of, can you send a screenshot here so that people will always also be able to see it? Okay, so yeah. So as you guys can see here, right, that she put an address in minting. Okay. Have you put for the receiver one while you're minting it? Is it your contract address? Is it someone else's contract address? When I enter the contract address, it was giving an error, invalid address. Okay. So in the minting, she put her address and she's put the amount as 500. And if she does the transact, she'll be able to see the balance as 500. Is it right? Where did you, okay. No, you got to first mint invalid address. How is it possible if you're copying the address and pasting it? Try doing it again. And then you're putting send, then to, and then in balances, you'll be able to see it. And then the transaction will work fine. So then, okay. So as you can see, so you already have so many addresses available, right? So just try experimenting like this. Put an address, put an amount, okay, mint it, and then check balance to see if it worked fine for you. Then put it at send, put an amount, transact it, see if the transaction worked, then check balance again. See if all of that is working fine for you. You can just play around with your smart contract like that. Okay, that I think do we have any doubts for today's session? If not, we can stop here. Transactions, blocks, and these other account stuffs and everything we'll take in the next class. We already had like a lot of discussion on the smart contract and everything. So I don't want it to be overwhelming for you. Are there any questions for today's class?
Yeah, I have one doubt here. Like, how can we generate the error, like the error that is given in Mint, the require message? How can we make it false? This somebody asked.
Which one are you talking? Oh, this message or sender equals to minter. Okay.
Yeah.
So, it should, okay, so I think it will work like this. Since you are initiating the transaction, okay, sorry, if you are minting it, the minter has your address, right? Now if you put some other address in the mint function, okay, apart from your address, when you're trying to do it, that will show you an error.
The main function takes receiver and amount. So
What?
receiver is other person only, and amount is also different. Like here, message dot sender is the address of contract or the account from which I generated the contract.
Yeah.
Acha, if I'll change that, then
Yes.
okay.
Okay. Any other doubts? If we don't have any doubts for the sessions, we can stop. Kiran, Priyanka, if you